So on Tuesday, we already learned the multimedia database. You can try to extract some figures with some keywords like this one. So we are going to learn about the feature descriptor. What does it mean by feature descriptor? When we are dealing with the image, we need to have the feature descriptor. It is a representation of an image or an image patch. Okay. Patch means some part of the area, okay, that simplifies the image by extracting useful information and throwing away extraneous information. So it means if we have important information here, we will use it. If we have not important information, we will just throwing away. Typically, a feature descriptor converts an image of size width multiplied by height multiplied by 3. So 3, it means this is 3 channels. If you still remember, we have the R, we have G, and we have P. What is it? Okay, good, right? Green and blue. So that's the basic color. So we have the RGB. Oh, sorry, I don't put there. This one. Right? Green and blue. Okay. So this is the basic color that can be represented in numbers. So once we have the width multiplied by height and the 3 channels, we can later make the feature factor or an array of length n. Okay. Let's see from this example. It is number 8. Okay. Can you see this one? This is 8. Okay. And this picture or this image, this number or the pixel values denote the intensity or the brightness of the pixel. So let's see this one. Can you see this is number 0? Okay. And then this is number 2, 15, 0, 0, 11, 10, 0, 0, and so on. Smaller numbers closer to 0, it represents black. So the color is black. Larger number closer to 255, it denotes white. Okay. So you can see if it is white, then the number is 255. 255. If it is black, the number is 0. Okay. Then you can look at the numbers here. So the higher number seems like, yeah, we can create like this one. Okay. So something like this one based on the numbers. So this area, it shows the color is more to white, and the other area is more to black. So how we can create this one? Yeah. So basically, yeah, in the image, there are some feature descriptor. The one that we just saw before, it is the grayscale pixel values. We can have also another pixel value, we call it min pixel value. We can have also another pixel value which is about the extracting edge features. We can use the histogram of oriented gradients. It's OG, or people usually call it Hawk features. In the case of histogram of gradient or Hawk features, the input image is 64 multiplied by 128 and multiply by 3. So this 3 is the 3 channel. And the output factor is the length of 3780. So this is the common Hawk features. So for example, I have the red color. The red color, it represents in 3 numbers. We call this is the R, G, B. So the R number is 255, the green number is 0, and the B number is 0. If it is green, then the R number is 0, the green number is 255, and the blue number is 0. If it is blue, then we have R is 0, green is 0, and the blue is 255. If it is magenta, this one, then the red is 255, the green is 0, and the blue is 255. If it is yellow, it is the combination of red and green, and the blue is 0. Okay. So whenever we have a kind of figures or image like this one, for example, then we can represent it with numbers. So what is the R? Maybe this one is 141. And what is the green? Okay, we have 35. And what is the blue? Okay, 31. So this number is representing the color of the image. When we have the grayscale, so we have only black and white. So the grayscale means just black and white. So as you already know, if it is 0, then it is more to black. If it is 255, then it is more to white. After we have these numbers, we can put it into array like this. So it means we have the number 0, 2, 15, 0, 0, 11, 10, and so on. We will make it as an array in the one row. So this is an array or a list 0, 2, 15, 0, 0, 11, 10, and so on until the last one. Until we have to value this one 0, 0, 14, 1, 0, 6, 6, 0, 0. Then we have all numbers from this image. So if the dimension of the image is 8 multiplied by 8, then if it is 8 and if it is also 8, then total number in this we have 64. If the dimension of the image is 28 multiplied by 28, so you can look at the figure or the image. If it is 28 and the height is 28, then the number, the total number here, it will be 784. It is the multiplication between 28 multiplied by 28. In some cases, the image has the dimension which is not same. Maybe 650 multiplied by 450. So in this case, the number of features will be 200,000, 97,000. So we can say that if the image is getting bigger or getting larger, the number of features is also getting larger. We can use the min pixel values. The min pixel values means, you already know we have the width, the height, and the 3 channel. So the width and the height, it represent the image width, the image height, and then we have the 3 channel. The first is representing the R. We have another matrix representing the G, and we have another matrix representing the P. So the 3 numbers represent the 3 channels. So we can go ahead and create the features as we did previously. So the number of features in this case will be this amount, because we are going to combine it. If you want to combine, then we will have that this one. Or we can make min. What does it mean by min? So the min will be this number 101 plus 35 plus 31. So the combination of R and G and blue, it will be divided by 3. So we will put it into this cell. So we call this is the min pixel values. Or we can do with the adds features. We can extract the adds features. What if the machine could also identify the shape as we do? Okay, when I ask you, what is this image? We know clearly that it is a puppy, a dog. But how the machine, how the computer know that this is a puppy? We know that, okay, this head, this shape is a puppy. So we can make the edges. We can extract edges as features and use that as the input for the model. So we just try to extract the edges line like this one. And then if the shape of these edges is similar to the dog or puppy, then okay, we can say that this picture is the dog picture. But how can we identify edges in an image? So basically, there is a sharp change in the color. What does it mean? So I would like to check if, let's say this metric is this one, this I. So I would like to check the changes. For example, this is the RGB values, 85. So the left one is 78 and the right one is 89. Then if it is unadds features, I would like to check the difference. So 89 minus by 78. 89 minus by 78. Okay, the difference is not that big. Only 9. Then I can say that the color is similar. Okay. Then it cannot be the ends. For example, I have another value, 125. So with this number, I would like to check the right and the left. 111 minus 68. Okay, so we have like 43. Okay, the number is bigger than 9. So I can say that this can be the x, because this left and this right is contrast. Yeah, we call it the contrast, while the right is higher, very big value compared to the left. So we call this is the edge of the image. If we can extract the edge, then we can determine the structure or the shape of this image. So finally, we can make something like this one. Okay. So we can figure out, okay, this is the edge of the image. Okay, this is the shape. And based on this shape, we can show something, we can determine what is this image. Now, when we are extracting the edge features, actually there are some ways to extract it. So I would like to introduce the pre-width kernel. The name is pre-width kernel X direction. If it is X direction, so we have the right and the left. The right contains of positive 1 and the left content of the minus or negative 1. If we call it pre-width kernel Y direction, we have the top and bottom. Okay. So the top shows with minus 1 and the bottom shows with 1. There are many other kernels. We call this is the kernel. Another kernel called Sobel kernel. The idea is still the same, left and right, but the weight is different. This one is minus 2, this one is 2. The Sobel Y direction, it shows top and bottom, and the middle is minus 2, and this one is 2. So the weight is different. So how can we use the pre-width kernel? Let's suppose I have this matrix here. And this is the input matrix. It is matrix 5 multiplied by 5. So I want to use the pre-width operators of y and the pre-width operators of x direction. Okay, gy, gx is the pre-width kernel x direction and the pre-width kernel y direction. We have gy and gx, so we need to calculate. Let's assume that we have the 3 multiplied by 3. So from this 5 multiplied by 5, I want to create 3 multiplied by 3. So what I can do for the first is to check the 3 multiplied by 3 for the first part of this matrix. So we can extract it and the result is 1, 2, 4, 5, 2, 5, and 5, 4, 2. If we use the pre-width operators gx, it means we have the 1, 1, 1, we have minus 1, minus 1, minus 1. So what we can do is, because we have all 1 at the right side, so this side we just have the positive. So 4 plus 5 plus 2. It means 4 multiplied by 1, it is 4. 5 multiplied by 1, it is 5. And then 2 multiplied by 1, so it is 2. What about the left one? The left one we have minus 1. Then we have minus 1 multiplied by 1. So it is minus 1. And then minus 1 multiplied by 5. So it is minus 5. And we have minus 1 multiplied by 5. So we have another minus 5. So this is the result. It's 0. Okay. What about GY? GY is using the private kernel with the Y, and this is the formula. So the bottom part we use the 1, 1, 1, and the upper part we use minus 1, minus 1, minus 1. Then we will use the same matrix, which is 3 multiplied by 3. So I will use the top and the bottom. The bottom part we can just multiply by 1. So I will have 5 plus 4 plus 2. And then the top one we should multiply with minus 1. So minus 1 multiplied by 1, minus 1. Minus 1 multiplied by 2, minus 2. Minus 1 multiplied by 4, minus 4. So we have the result 0 and 4. So we need to take the absolute values of both. So we need to make absolute of this. Making absolute of this, then we will sum them. The result will be 4. So this is the first top value of the output image. So using this one, we can have a new number which is 4, and we create a new matrix like this. So what next? Next, we will shift, okay, not the first one only, but we will shift checking the next row. So we have 2, 4, 5, 2, 5, 6, 4, 2, 7. And again, we will do with the GX and the GY. What is the GX? We have the 1, 1, 1 on the right. So it means 5 plus 6 plus 7. And then we have minus 1 on the, 1 in the right and minus 1 on the left. Then we have the 2, 2, 4 as the negative. Minus 2, minus 2, minus 4. Okay, we have 10. When we calculate the GY, yeah, we use the private operator. This one, 1, 1, 1, minus 1, minus 1, minus 1. Then it is 4, 2, 7, or 2 plus 7, minus 2, 4, and 5. 2, 4, and 5. So we get the result, it's 2. After we have this one, then we will check the absolute value for each of the result. So we have the absolute value of this, you have the absolute value of this, and we sum. The result is 12. We put 12 in this cell. The next step is, we will do on the next 3 multiplied by 3. So using this one, again we have the GX, GY, using the private operator. This is the private operator for X direction, and this is the private operator for the Y direction. After this, you have the 2 plus 2 plus 1, minus 5, minus 4, minus 2. So we have minus 6. And the GY is based on this one. Okay, we have minus 1. So if we look at the previous one, we have the function absolute value. So whenever the value is negative, we need to make it positive and sum them. So we have the minus 6, we absolute it, so we get the result 6. And then minus 1, we also make absolute, so we get the result 1. And the final point is 7. We put the 7 in this cell. So this is the final result. This is the final result from this simple input image. We can say that, okay, we have the input image is 1, so we can reduce into these numbers. or this is the feature descriptor using the adds features. So when we deal with the multi-dimensional analysis of multimedia data, we may deal with the multimedia data cube. Just remember what is data cube? A cube. Okay, we have a cube like this one. If you look at the data cube section before the mid exam, you will find something like the item. So what is the item? Computer, smartphone, or electronic devices. And then we can have time. So we want to save it for every month, or we want to save it for every year, or we want to save it for every quarter. Okay. So you can split it. And we can also consider the location. If it is sales in US, then you can have the location USA. If it is sales located in Korea, then you have another country named Korea. This is the traditional data cubes. So in the multimedia, we can also make this kind of data cube. It is similar with the relational data. And it contains additional dimension and measures for multimedia information. For example, texture, color, and shape. The database does not store images. So whenever you have images, they will not store it, but they will just get the feature descriptors and then they save the descriptors into the database. So feature descriptor is a set of factors for its visual characteristics. So you already know we can use the pixel, we can use min pixel value, or we can use the adds features. The most common feature descriptor is the color histogram. We can also do with the MFC, most frequent color factor, for example, 5 color centroid. Or we can use also MFO, most frequent orientation, 5 adds orientation centroid. Rather than feature descriptor, we can also deal with the layout descriptor. So any image, they will have the layout. So the layout will contain a color layout factor and an adds layout factor. So this is one example about the multimedia minor. So do we make the categorization? Like what is the entity? You have causal agent, life form, object, and etc. So this is the collection of Boeing. Okay, Boeing is a manufacturing airline company, and this is the collection of the airplane from Boeing. So whenever we use the data cube, okay, we can make the cube like this one. For example, for the starting point, I want to know how many of the figures containing red, how many of the figures containing more white, how many of the figures or images that containing blue. So you can check another dimension. For example, I know that I want to check the red, white, and blue, and I know the file type. Maybe the file type is JPEG, and the other file type is GIF. So I can check if it is JPEG, how many of them are in the red color. If it is GIF, then I want to know how many of them there are in the red color. And also we can make it into the 3 dimension. The 3 dimension here, for example, we have the type, we have the bicolor, and by the size, and so on. So you can have the format of image. Okay, so this on the JPEG chip. You can also say the duration, because in the multimedia database, usually we can also deal with the video, not only image. Colors. So you already know the histogram, the hot pictures. And the textures, keywords, size, width, height, internet domain of image. So if you go to Google, if you click the image, there will be many images, but it is not originally from Google. Google just search all the pictures in the World Wide Web. So it means we can give link to the image. Or the internet domain of the parent page. Let's say we have the official Hamburg website, and whenever we have the internet domain, so for example, in our department, we have ime.hub.ac.kr. Then, in the domain of the parent page, it will be included. For example, whether it is in the parent of the university, or the IME belongs to the engineering faculty, okay, or the industrial engineering belongs to the global campus. So we can have some parent or hierarchical structure, image popularity, and so on. So the dimension can be anything. So you can make different dimension to create this kind of data cube. If you learn the classification, what is classification? Classification, given the data, then you can classify whether the person will buy a computer or not. So this is the same. Given the data, given the picture, can you classify whether it is book or not? Okay, those pictures are collection of books. Those pictures are collection of animal. And this picture contains a lot of flower. So we can make this kind of classification or multi-class classification depending on the label. So the special features for mining association. You know association? Okay, so in the first part of our lecture, we learn about the association rule. What is association rule? We want to check the association between item at the time. Let's say I have milk. So I want to know what is the support and the consequence if someone buy milk, he or she will buy bread. Okay, then this is the association. We can also have this kind of association in the multimedia database. For example, the number of occurrences beside the bullet existent. For example, I want to check 2 red square and 1 blue circle. So if I have these 2 properties, does it imply ratio? Okay, so we can make the association. So if this item set 2 red square and 1 blue circle implies ratio. What is the support and what is the confidence? The spatial feature needs spatial relationship. What is the spatial relationship? Blue on top of white square object is associated with brown button. So you can have like user interface, for example. So in the user interface, we may have like button, or we have like the header. So you can mine. You can do the mining with this kind of data. Let's say, is there any relationship between the bottom and the top? So if all website, they show that there's a correlation between bottom and the top, then when you want to create a new web page, you need to consider the same. Maybe that is the pattern. And need multi-resolution and progressive refinement mining. So the multi-resolution means, yeah, it is expensive to exploit detailed association among objects at high resolution. So maybe I have the picture, so I can reduce the resolution, and then I can reduce the resolution, and then I can check what are the association in this image. Maybe when I look into the class, there is a table. Okay, so I have class. Oh, every class is associated with table. Then, yeah, you can do something with that. And it's crucial to ensure the completeness of each of the multi-resolutional space. So if it is the multi-resolution, yeah, of course it is more complicated. Okay, let me stop here. Let's have a break. I'll continue after break.